Good evening and good morning, everyone. This is Michelle Mengqingqian, General Manager of Electronics and Physics Department of SPTL. Thank you for joining us today. I'm very glad to have Ms. Yue Cai here as our speaker. Mr. Yue Cai is a Deputy Head of Electronics and Physics Department 1 at SPTL. He joined SPTL in 2005 and is an experienced patent attorney. Mr. Cai has served our important clients in areas of computer software, telecommunication, and vehicle control, providing patent prosecution, patent invalidation, infringement analysis, IP portfolio management, as well as IP strategic counseling. In recent years, Mr. Cai has accumulated rich experiences in handling AI cases related to automated driving, big data, and financial technique. Today, his topic is about interpretations of amendments to guidelines for patent examination related to AI inventions in China. Okay, now I'd like to hand over to Yue for him to start his presentation.
Okay, thank you, Michelle. Also, thank everyone online for joining us on this topic. And I believe that most of you may have heard that China and the United States are the two countries leading the research and development of AI technology, and also leading the most patent filings for AI inventions. So just like everywhere in the world, AI is now widely used in China, not only in our daily life, but also in many industries, such as automated driving, the security, the manufacturing, the financial, etc. So with this booming development of AI, how to protect AI-related inventions by patents is a hot topic these years in China. And as far as I can remember, since CNIPA amended the guidelines for examination several times in the last 10 years, seeking for better meeting the demands and the requirements for industry, and to facilitate the further development and the application of AI technology. And the latest amendments was made in the end of last year. So today I would like to try to make some interpretations of the latest amendments to guidelines for patent examination related to AI. So today's webinar will cover these three parts. First, I would like to introduce what are the current examination procedures and the standards for the eligibility of AI inventions. And then we will see what are the new amendments to the guidelines for eligibility standards, particularly for AI and big data inventions. And in the last part, we will talk about the inventiveness examination for AI. Okay, so now let's move on to the first part. Okay, before we talk about the change, let me briefly introduce what the current standards are for examining AI inventions. So for AI inventions, they are those kind of inventions that typically make use of AI technology, including deep machine learning, neural network, and they are implemented by computers. So therefore, AI inventions are examined following those provisions and the standards for computer-implemented invention from the beginning. So the flowchart here are the examination process for computer implemented invention. We also call it CII. So the same process are used for AI inventions. As you can see, the process in China is more similar to that in European as compared to the United States. So both European and China divide the process into two phases. The first, the eligibility, and then the inventiveness. And the difference may be that in EPO, there's only one step for eligibility determination. Does the claim contain any technical character? So if yes, it passes and goes to the novelty and the inventiveness assessment. But at the inventiveness assessment stage, still some non-technical features will be taken out and considered as not contributing to the inventiveness. While in China, we have two steps in eligibility determination. So first, we also check if any technical features are included. So that's step one here. And then China has another step, we call it technical solution check. So which is to check if the solution is a technical solution, which means the solution must solve a technical problem, and the technical problem must be solved by technical means. So that's step two. And I personally further divided it into step 2.1 and then step 2.2. Okay, first for step one, it is quite simple. Any technical features can make it pass. So like processor, storage unit, image data, sensor data, anything will do. So the only examples that does not include technical features may be a completely mathematical model based on an abstract algorithm or some economic method like providing rebates such as awards or royalties points to customers based on their consumption amount. So this is not technical, right? And so anyway, step one is still checks only if there is any technical feature. So even for these two examples, it is still easy to pass the step by putting some processors or computing units into the claim. So to they are used to implement the algorithm. So in the form, it looks like they still have technical features and can pass the step one. But such amendments may still not help passing step two. So let's move on to step two. So here, still remember, we first check if it solves a technical problem, and then if it solves the problem by technical means. So let's back to the previous example. Encouraging customers to consume is not a technical problem, and giving them incentive of any kind is economic means, not technical means. So no matter the claim contains or make use of AI or whatever, it still cannot pass step two, and thus they are not eligible. So, and some of the examples of solving non-technical problems are that like price prediction of financial products like stocks, and also maybe improvement of the AI algorithms per se. They are not technical problems. So because the first one is that it is an economic problem, and the second one is because it is not connected with or limited to any specific technical field. So that's their problem. And step 2.2 here, maybe a little bit more difficult to judge. So sometimes some people will ask that how can we say a problem is solved by technical means, and how could it not be solved by technical means if AI technique is used here? Okay, that's the question, but I can give you two requirements that may help to understand. So according to the guidelines, first one is the algorithm should have close relationship with the technical problems to be solved. So for example, the data processed by the algorithm should have exact meaning in a certain technical field, like image data, voice data. So they are exact. They have exact meaning in certain technical fields. But like features, vectors, training data, items, these kind of features, they look like technical, but they do not have exact meaning if no definitions for them is given into claim. And the second requirement is that the execution of the algorithm can directly reflect the process of making advantage of laws of nature instead of man-made rules. So for example, solution use facial feature points, the frequency features, as to train a model for face recognition or voice recognition. And these features reflect the laws of nature. And on the contrary, if it only reflects laws of economics, or maybe the weights of the model are all man-made, this would probably be considered as the problem is solved by non-technical means. Okay, so next we will see some new eligibility standards for AI and big data inventions. So, generally speaking, CNIPA now provides two new standards that we believe are kind of relaxing the eligibility restrictions for AI inventions. So according to the introduction in the previous slides, you may feel that the existing standards in China quite require kind of, we call it technicality. So it asks the claims to reflect the exact technical field to the solution is for. And however, there was also some innovations that can be broadly applicable to many fields. So in the past, CNIPA considers such improvements as improvement to the algorithm per se and denies their eligibility. And now after amendments to the guidelines, if the solution relates to improvements of AI or big data algorithm, and if several requirements are met, and then some of such improvements can be eligible. So first standard here is called improvement to internal performance of a computer system. So if the algorithm features have specific technical association with internal structures of a computer system, and the solution is able to solve a technical problem of improving hardware processing efficiency or execution results, such as reducing the amount of data storage or data transmission or improving processing speed, then it is eligible. So for these two conditions, you can see the second one regarding the technical problem maybe easier to meet. So, but for the first condition, how to determine if the algorithm features have specific technical association with internal structures of a computer system, it looks like more difficult. So let's see some typical cases that may help you to give out a better judge on this point. Okay, the first typical case is what we call it as improvement to the algorithm per se. So let's look at the claim. It's a training method for the classification model, comprising the steps of training a classification model based on the preset data set, identifying each data in the preset data set based on the trained classification model to obtain category information for each of the data, and cleaning the data to obtain the target data sets, and training the classification model based on the target data set. So this is quite typical model training method for AI. So the problem is that all features in these claims are not limited to any specific technical field, right? And actually, they are not limited to any specific application field, I think. So it is not clear what kind of data it is. And it could be any data in any fields. So in other words, the method of this claim is for general purpose and can be widely used. So, but such kind of claim is considered as the improvement to the algorithm per se. So since it does not any limited any specific application field and does not reflect any technical association with internal structures of a computer system, then we call it it is an improvement to the algorithm per se. So it is not eligible. So this is the first case. And the second case, we call it hardware is simply a carrier for running the algorithm. So let's look at the claim. It's a sample category tag correction method, comprising the steps of clustering the first sample set and the second sample set, determining the distance between the first cluster and the second cluster, and determining the target cluster pair satisfying a set distance condition according to the distance between the first and second cluster. Okay, so it should be clear that the claim here has basically the same problem as the last case. So it is a general purpose algorithm, and the improvement is to the algorithm per se. So similarly, it is not eligible since it does not reflect any technical association with the internal structures of a computer system. But here, maybe a question: what will happen if we put in some computer system features into the claim? And it's kind of what we will do in some cases. So the underlying portions of this claim, we can say some added computer system features. So now the method is used in the server, and there's a processor that obtained the first sample set and the second set, and via a communication interface of the server and the processor using the clustering algorithm pre-stored in the memory to cluster the first and the second sample set. So the processor calling the distance algorithm stored in the memory to determine the distance between the first cluster and the second cluster. Okay, so after amendment, it looks like that there are much more clearly computer system features: the server, the processor, the memory, the communication interface. However, what we all know that the computer system is a common computer system. It does not have any change in hardware. It is only used to implement the steps of the algorithm. So in other words, general purpose computer system runs a general purpose algorithm. So therefore, the hardware features are considered not technically associated with the algorithm steps, and so it is still not eligible. So next, let's see some eligible cases. So this case is what we call it as features are closely associated with computer system structures. So the claim is a method for unwrapping tensor data of a convolutionary neural network. So from the subject matter, it still looks like an abstract algorithm. And so what makes it different from the last two cases? Here, the blue color feature is the key. The expansion dimension is determined not only according to a first tensor, but also according to hardware specification of a convolutionary neural network accelerator. So which means in this claim, the convolutional neural network accelerator is not only a hardware component that performs data computing and processing, but it is taken as a conditional parameter that constrains the execution of the algorithm. So the algorithm features and the computer hardware features now can be considered functionally support each other and interact with each other. So in such case, the algorithm features have a specific technical association with the internal structure of the computer system. and so it makes the claim eligible. Okay, so this case is what we call it as hardware or software resources of a computer system are scheduled. So the method is also for training the deep neural network model. So the special feature here is in this claim is the blue colored one. The at least two candidate training schemes comprise at least one single processor scheme and at least one data parallel based multi-processor scheme. So more specific, if the data amount is more, the single processor scheme is more suitable. And if the data amount is large, so the data parallel based multi-processor scheme is more suitable. So now we can see the solution is not to improve the machine learning algorithm per se. It proposes performing training with different and suitable training schemes so that time and efficiency for data training can be improved. So now we can say that the improvement of the internal performance of the computer system is based on close combination of different data training methods and the execution process of the processor, which improves the overall execution effects of the computer system through the scheduling of computer resources in the distributed system. So it is eligible. And last but not least, if a claim relates to design or improvement of AI chips, design of a multiprocessor system architecture dedicated to a certain kind of algorithm or some improvement of hardware structure or system architecture of a computer system, such a claim is surely eligible since it directly relates to something that is completely hardware improved. Okay, so let's have a brief summary of all of the above 5 cases we have just discussed. So the first 2 cases, if the improvement is only about the algorithm per se, or not limiting or reflecting any technical field, then it is not eligible. And it is still not eligible if we put some general hardware features into such algorithm claim, since the hardware is simply a carrier for running the algorithm. And the next 3 cases are eligible if the features are tightly associated with computer system structures or scheduling hardware or software resources, or completely hardware improvements. All of these 3 cases will be considered that the algorithm features have specific technical association with internal structures of a computer system, and it is able to solve a technical problem of improving the hardware processing efficiency or execution results. So they are eligible. So, but after all, you may ask, what exactly is the meaning of this new standard 1? So, I think to answer this question, let's get back to compare the current standards, or we call it general standard, and the new standard 1 for AI and big data algorithm. So in the general standards, it asks that the algorithm to have close relationship with technical problem to be solved. And then further asks that the data in the claim should have exact meaning in a technical feature, just like here, the image data, voice data here. And once you define the data, the technical field of the claim is limited. And for the new standard 1, it only asks the algorithm features should have technical association with internal structures of a computer system. So here, the technical association does not equal to or require a limitation of a technical field. So still remember the 3 eligible cases. And let's take the first case as an example. So here we discussed before, this claim is eligible for its scheduling hardware resources of a computer system. And in this claim, the blue colored features is the key to meet the standard 1, and that's enough. So you may notice that the training data here are maintained without limitation to any specific technical field. So answering the question, what exactly is the meaning of this new standard 1? So if the solution meets standard 1, then no limitation to specific technical field is required. And so the solution is still widely applicable to any field and any scenario. So the data could be any data. So the protection scope can be broadened. And I think that's the meaning to have this standard. And the other standard is for big data processing. We know that the core of big data technique is to mine the relationship between input and output. So this standard actually puts only one requirement, which is that the relationship should reflect making use of laws of nature instead of laws of economics, sociology, or psychology. So if the data connection complies with laws of nature, then the technical problem can always be met. Since for almost every new algorithm for big data, we can always say that it improves reliabilities or accuracies of data analysis in the specific application fields. Then the requirement for standard 2 is met, and in such case, similar to standard 1, it is allowed, not limiting the claim to technical fields. Only an application field is required. So the key point is whether the data connection between input and output complies with laws of nature. So let's see an example. Okay, so let's say that there's now a method for personalized recommendation. For example, recommending a car to a potential customer with big data. So as usual, a recommendation that model needs to be established, and usually based on historical user data. So in particular, the training model, the training data set will be what cars the users own and the personal data of the users. So they are input and output, and now combined as a data set, or we call it training data pair. Okay, so as an example, if the method uses the user's blood types and star signs as training data, and build a model, and gives out a recommendation based on a new user's blood type and the star sign, and this connection between car and the blood type plus star sign, this connection does not comply with laws of nature, and then it is not eligible. And on the contrary, as a comparison, if now the method mines the user's network browsing data and find out the customer spend much more time searching and viewing articles or videos on the particular car model than any other model. So it predicts this customer may be interested in this model and gives out a corresponding recommendation. So this connection between the browsing data and the car complies with laws of nature, and it is eligible. Okay. So let's summing up. After the amendments to the guidelines for examination, now we have a kind of new flow chart for eligibility determination for AI invention taken by the examination from CNIPA. So first, we will check if this solution relates to AI or big data. And if not, it follows the general procedures. Remember, the first step, does it contain any technical feature? And the second step, does it solve a technical problem and solve it by technical means? And on the other hand, if the solution does relate to AI or big data, then we can follow the new procedure. So we determine does the data process by the solution have exact technical meanings? And if yes, using the normal procedure is enough. And if not, then we have the two new standards to use. And meaning either of them can make the solution eligible. And if neither of them is met, so it is not an eligible subject matter. Okay, so that's all for the eligibility phase for AI inventions. And now let's move on to the next phase, inventiveness. So for inventiveness assessment in China, a general rule is that if the algorithm features and technical features functionally support each other and have interaction relationship between them, then the contribution made by the algorithm features should be considered. So that's a general rule. And in the latest amendments to the guidelines for examination, I think it just further clarified that how to determine the algorithm features and technical features functionally support each other and have a so-called interaction relationship between them. And then you may notice that it basically follows the same rules of the standard one we mentioned before for the eligibility. For example, it also requires that the algorithm has a specific technical association with the internal structure of the computer system, realizes the improvement of the internal performance of the computer system, and improves the operation efficiency or execution effect of the hardware. And so if these are met, the contribution made by the algorithm features to the technical solution should be considered. So therefore, if the claim passes the eligibility check through standard one, then the solution should have inventiveness, or at least considered, will be considered in the inventiveness assessment. And unless a same or similar prior art is found. So usually you will feel that it may be easy and kind of relief at this stage, since you do not need to worry about the algorithm features will be taken out, or only some general hardware features are left, like some cases in the EPO. Because the claim has already passed through the eligibility check in China, and at least some of the algorithm features are acknowledged by the examiner to have close relationship with technical features, and therefore at this stage, at this inventiveness assessment stage, such algorithm features and the technical features will be taken into consideration as a combination for inventiveness as a whole. And another new amendments about the inventiveness is about the improvement in user experience. So in the past, there were some disputes on whether improvement in user experience can be accepted as technical effect, since user experience may be personal and subjective. But however, the user experience improvement is also a very common purpose of development, especially in software area, and also in product design. So if user experience improvement doesn't count, then sometimes it may be difficult to find another appropriate technical effect for the solution. But fortunately, after the amendments this time, it is clear that if the improvement in user experience is brought or produced by a technical feature or by algorithm features closely related to the technical feature, then the improvement in user experience should be considered as technical effect. So, in my opinion, this new standards will be quite useful for inventions related to big data, if only it meets the requirement of standard 2, which is the data connection between input and output should comply with laws of nature. And then you can say, based on the use of big data, the reliabilities or accuracies of data analysis are improved, and then the user experience is improved. So basically, you don't need to worry about the difficulties in outlining some new technical effects for these solutions anymore. Okay, so that's pretty much for today's topic, and hope you can get a clearer picture of the examination procedures for AI inventions in China, including the eligibility check, inventiveness check, or some others new standards and amendments. And okay, so we still have some time for question and answers.
Okay, thank you, Yue. Now let's move on to some Q&A. Let's see what kind of questions do we have. Okay, we have one question here. This question is from Ms. Richard Mirror. His question is, for the last slide about the user experience improvement, you mentioned that a better or more accurate prediction produced by big data can be considered as experience improvement. What if the algorithm or a method is not related to big data? Can the user experience improvement still be considered as technical effect? Yue, please give your answer.
Okay. First, thank you for your question. If I understand correctly, you are asking if the algorithm is not related to big data, but still tries to improve in user experience, how to determine whether the improvement in user experience is technical effect or not. Okay, so I think this is quite a good question, and indeed, as you mentioned, the new amendments make it easier for big data algorithms, but for other user experience and improvements, I think we may still need to get back to determine what exactly results in the improvement. It is kind of similar to the eligibility check. I remember at step 2, we check whether the solution solves a technical problem and whether it is solved by technical means. So usually the technical means are more critical in most cases. So if the user experience improvement is brought by technical means, and that technical means is the technical features or algorithm features closely associated with the technical features. So if it is brought by technical means, and then the user experience improvement can be considered as technical effect. If the user experience improvement is only brought by algorithm features, and the algorithm features do not show any close association with technical features. So such improvement will still not be considered as technical defect. And actually, it is very likely the solution will fail in eligibility check and not even reach the inventiveness phase. That's my answer. Hope it's clear for you.
Thank you, Yue. It is quite late here in Shanghai. If you have any further questions, please contact us anytime by phone or by email. Thank you so much for your time today. Goodbye.
Thank you. Bye-bye.